If Earth were shrunk down to the size of a soccer ball, where would the moon be? 1 meter away? Maybe 10? The answer is about 6 to 7 meters. And yet, this is still one of the easiest distances in the universe to imagine. Today, we're going to shrink the universe 3 times to understand just how enormous it really is. Then, we'll compress the entire history of the universe into a single year and see how recently humans arrived. Imagine Earth as a soccer ball about 22 centimeters wide. At this scale, the moon would be a small ball about 6 centimeters wide, placed 6 to 7 meters away. That already feels like a lot of empty space, doesn't it? But the sun would be much, much larger. At the same scale, it would become a gigantic sphere, about 24 meters wide, and it would be roughly 2.6 kilometers away from our soccer ball Earth. Jupiter's orbit would be about 13 kilometers away, while Neptune would be nearly 80 kilometers away. But the most astonishing distance is the one to Proxima Centauri, the closest star to our Sun. In this model, it wouldn't be on the other side of the room or even on the other side of the city. It would be around 700,000 kilometers away, almost twice the real distance between Earth and the Moon. Most of the space between stars is almost completely empty. Now, let's shrink everything again. Imagine compressing the distance from the Sun to Jupiter's orbit into a single coin. The Sun sits at the center while Jupiter travels around the edge. Even at this scale, the nearest star would still have to be placed hundreds of meters away, and the entire Milky Way would be roughly comparable in size to Australia. The Milky Way contains hundreds of billions of stars, and our Sun is only one very ordinary star among them. Even inside such an enormous galaxy, the stars are not packed tightly together. They are separated by vast regions of dark, empty space. So what about the Andromeda Galaxy, the nearest large galaxy to the Milky Way? At this scale, it would have to be placed somewhere near the moon. So, let's shrink the universe one more time. This time, imagine compressing the Milky Way, which is about 100,000 light years across, into a coin sitting on your desk. The Andromeda Galaxy would become another coin, placed less than 1 meter away. Farther out, the Virgo cluster, located more than 50 million light years from us, would appear over 10 meters away. But instead of containing just one coin, it would contain more than 1,000 galaxies gathered together. If we continued traveling outward, we would see more galaxies and galaxy clusters forming an enormous cosmic web, stretching in every direction, all the way to the edge of the observable universe. As for how much space exists beyond that boundary, we still don't know. These distances are already difficult to imagine, but the timescale of the universe is even more extreme. Imagine compressing the universe's 13.8 billion year history into a single calendar year. On January 1st, the Big Bang happens. The first stars and galaxies begin to appear during January, but our solar system and Earth itself doesn't form until early September. The earliest signs of life on Earth appear later that month. Animals and plants don't arrive until around December 20th. Dinosaurs make their entrance around Christmas before disappearing near December 30th after an asteroid strikes Earth. Modern humans appear at approximately 11:50 p.m. on December 31st. The first humans arrive in Australia with only about 2 minutes left before midnight. The earliest written records appear during the final few seconds of the year. The height of the Roman Empire and China's Han Dynasty happens with only around 5 seconds remaining. The Industrial Revolution begins during the final half second. On this cosmic calendar, an entire human lifetime lasts less than 0.2 seconds. We are incredibly small and we arrived remarkably late. And yet, this species, which has existed for only a tiny moment, has learned to measure stars, observe distant galaxies, and search for an explanation of a universe far beyond its own scale. In the next episode, we'll explore how astronomers use scientific notation to write numbers so enormous that they would otherwise be almost impossible to read.